Hi, I'm Rhonda Miller and we're at the Lewiston Irrigated Pasture Facility to look at a study that involves several scientists from Utah State. In this study we're trying to find best grazing system for developing dairy heifers. And so part of what we've been doing over the years is first we looked at trying to find the best legume to add into the mixture. We found that bird's foot trefoil works very well here. Then we started looking at the different grass monocultures and grasses with that bird's foot trefoil and found some of those. And now we're starting to look at the different breeds of dairy heifers and to see what combination makes for the very best system. We're looking for the best rates of gain, the good reproductive development, and we want it to be economical and environmentally friendly. When we add a legume to the diet, we add a lot of nitrogen into the system. It increases the protein content of the feed, but it also adds a lot of nitrogen that can create environmental problems. It can also potentially create some reproductive development problems, so Dr. Isom is looking at that. On the environmental side, we are looking at what happens to the nutrients. Are they leaching past the root zone into the groundwater, or are they being utilized by the plants? To do that, we are looking at the yields and the forage growth and the protein content in the forage. We're looking at how much is left in the field and trampled. And then we're also looking at the nutrients that are in the soil, both in the top part of the soil and deep down. We take soil cores down to 5 foot deep in segments so that we can see where those nutrients are really residing. And we take soil samples at both the beginning of the grazing season and at the end. The reason for that is in previous studies, we've seen that nutrients leach a lot with the snowmelt. So we want to know if we're losing a bunch over the winter. We also look at the leachate. So that's the soil water that moves down past those roots. And once it gets below the plant roots, it will then end up in the groundwater. Here we are at our trailer. It's kind of the heart of our zero tension lysimeter system. If you'll look on the wall, we have different ports there. That's how we access our zero tension lysimeters. The zero tension lysimeters are actually 15-inch diameter by 44-inch deep soil cores that were extracted. We put on a collection and reservoir system, put them back into the ground where we extracted them from across the field. And then we have PEX tubing running down way below the soil surface up to the trailer, and it comes up through those access ports. We then put on a vacuum pump and collect the leachate in those big bottles. We measure the volume, and then we take a sample back to the lab to analyze for the nutrient content. And here we are at one of the suction cup lysimeters. We have little metal plates on top of little irrigation covers, and then inside of that is actually a PVC tube, 2-inch diameter, that's 3 foot deep with a little ceramic cap down at the bottom. There's a stopper and an access tube on the top. And Marcus will show us how they collect those samples. On those tubes we put on a vacuum, and that vacuum pulls soil water through that ceramic cap down at the bottom. And so he will open it up. You could hear there's a little bit of a vacuum. We'll put the little tiny tube down that, suck out the leachate, get that, measure it, take a sample to be analyzed for nitrate, and then we put a vacuum back on that little tube, close it off, put it back under there, and come back every week to go get a new sample. We do this from the beginning of the growing season till the very end. So during the true winter months when we're covered with snow, we cannot get samples off the suction cup lysimeters.
So I just write down what suction cup lysimeter it is, so 105, the date, and then how many milliliters we pumped out. Okay.
And so then we keep a sample to analyze. We keep those cold till we get back to the lab, and then we analyze them for nitrate. We record the volume that we've collected, and then Marcus will put a vacuum back on that suction tube so that it can be pulling in the leachate the next week. So we have to pull that part out. And we go till we get to between 60 and 70 on the vacuum pump so that we're at about the same vacuum pressure each time. We put these little rings over to lock it, to hold that vacuum on there, close it back up. Theoretically, just the irrigation covers should be enough and strong enough to hold the little heifers, but we don't necessarily trust that, we put the metal plates on as an additional protection. So here we have one of our root tube cages. We have two acrylic root tubes in here. Bailey will show how we do that. We first pull out the little stopper, and you'll note it has a black styrofoam tube in there. That's to help intercept and block any light, because light down there would change how those roots grow. We run a little towel down there to make sure there's no water in the bottom, because the scanner does not like water. That destroys them. So we make sure it's good and dry. And then she will drop down this little cylindrical scanner. And it's really just like a scanner on a copy machine, but it's round and it fits in that little tube. And you put it down and it spins around and takes a scan of the roots all the way around that tube in 1 foot increments. And so it records a picture image on the computer. We then take those back to the lab. We load those images. We can then trace the roots and stitch the images together, and we can get a good description of the total root mass, the root volume, length, and things like that, and the distribution, so that we can see if there's differences in the different grasses and grass legume mixtures. And we hope that that will help explain some of the differences we're seeing in nutrient leaching.